Hello everyone. This is goal number 8. This is probably one of the more challenging ones in this unit because what happens is now instead of me telling you specifically what method to use for factoring, you have to go through a mental checklist to determine what's the best way to factor the problems. And in all these problems, chances are you're going to have 1, 2, maybe even 3 steps to do. So here's the checklist that we have to remember to go through, and this is all the stuff we've learned so far in this unit. When you're going to factor a problem, to start off, first thing you want to do is determine, is there a GCF? If there is, great. Take it out and that'll make your life a little easier. From there, you need to determine, are there 2 terms? If there's only 2 terms, there's only 3 possibilities for it. It's going to be difference of squares, sum of cubes, or difference of cubes, which means you have to use those formulas. When there are 3 terms, that means we're going to have a leading coefficient of 1, or we're going to have a leading coefficient not equal to 1. And we have leading coefficient not equal to 1, we're going to use bottoms up. The last thing to check for is if there are 4 terms, there's only one way to do that, and that's to factor by grouping. So at any point, if you need help with any of these methods, go back and watch videos 1 through 7, and then we'll help you on how to do all those methods. So here's what our actual problems are going to look like. Let's zoom in one at a time on them. So the first problem that we encounter, and feel free to pause anytime you want and try to factor it on your own, is 15x cubed minus 9x squared minus 6x. Start off with the basics. Is there a GCF? Sure enough, yes there is. They all have a 3x in common, so if we take the 3x out, we're going to be left with 5x squared minus 3x and then minus 2. Now that we've done that, we look and determine that there are 3 terms. And there is only 2 possibilities, leading coefficient equal to 1 or not equal to 1. In this case, it's not equal to 1. Which means we're going to do bottoms up. When we do bottoms up, let's go ahead and set this up. We end up with a negative 3, a negative 10. Remember that's your A times C value right here, 5 times negative 2. The factors of negative 10 that will add up to negative 3 are going to be 2 minus 5. From here, remember we now divide both of them by our A value, which is 5, so let's divide by 5. And then we have to make sure we reduce each one of them if we can. Sure enough, this one reduces. So my first factor down here is going to be an x minus 1. The second factor is going to have an x plus 2/5 since this won't reduce. And so if we take the bottom and move it up front, we end up with a 5x plus 2. The last part of this that we can't forget, and most people do forget, is that since we took out a GCF in the beginning, this has to be carried through to our answer. So that means we're going to have a 3x in the front. And this is our final answer. So we took out a GCF, and then we were able to factor using the leading coefficient equal to 1. Okay? That's your first problem. Here's problem number 2. Again, pause it, try it on your own, and then come back and check if you'd like. So when we look at this, first thing we should notice is it's not in standard form. And when it's not in standard form, we have to rewrite it in standard form before we can start factoring. So this will be a negative 2x cubed and a positive 16, excuse me. So first question, is there a GCF? Yes, there is. Not only is there a common value between these, which is 2, but because the leading coefficient is negative, we have to factor out a negative. So we're going to take out that negative 2, and we're left with x cubed and then minus 8. Now we look at these 2 values here, and we notice that there's only 2 terms, which means the possibilities are difference of 2 squares, sum of cubes, and difference of cubes. This happens to be a perfect cube, and this is a perfect cube. So that means the form is difference of 2 cubes. So let's go ahead and set this up. We have a negative 2. Look back at your difference of cubes formula, and you'll remember we're going to have an A. Let's see, the A here is x, the B here is 2. So we're going to have x minus 2 times x squared plus 2x plus 4. So we have same, opposite, plus, and we're just using the formula to plug it in. And so this is our final answer. Okay, let's go ahead and try letter C. Same thing, pause it, try it, and then check your answers. These have a value of 5, 20, and negative 15 have a common value of 5. And since the leading coefficient is negative, we're going to take out a negative. And they all have an x in them. So we take out the 5x, and we're going to be left with x squared minus 4x plus 3. Once we factor this, we notice that there's a leading coefficient equal to 1, and there are 3 terms here. So that means we have to figure out what are the factors of 3 that will add up to negative 4. So think through, there's only a couple factors of 3, and that just happens to be 1 and 3, which means that we're going to have an x minus 1 and an x minus 3. This is your final answer. And then our last problem. Okay. Again, look for any GCFs. Let's go ahead and take it out. This is a 40, sorry. And they all have a 10 and an x in common. So that means we're going to have 10x times 4x squared minus 9. From there, we can tell that because we have 2 terms here, they can only be sum of cubes, or difference 2 squares. In this case, it's perfect square, perfect square, perfect square, and it's the difference. So that means we set this up. Square root of 4 is just 2. Square root of x squared is just x and x. Square root of 9 is 3 and 3. And then plus and minus. There we go. There are tons of different possibilities for the problems that you're going to see. I can't possibly go through and do all of them in the videos, but follow the checklist and you should be able to go through and do any one of the problems that you might encounter. Hopefully this helps. Give it a shot and come in and see me if you need help on anything else, okay? Have a good day.